Assalamualaikum. Welcome to my channel Educational and Technical World. Kindly subscribe and share my channel. Today
We will discuss about chemical bonding, sigma and pi bonding. So let's get start our today's session. Chemical bond is the force of attraction that holds atom or ions together to form a variety of compounds. Now we discuss pi bonding and sigma bonding. Sigma bond is a single bond that is formed when two partially filled atomic orbitals overlap in such a way probability of finding electron is maximum around the line joining of two nuclei. While pi bond is formed by parallel overlap of p orbital when two half-filled orbitals overlap in such a way probability of finding electron is maximum above and below the line joining of two nuclei. Here is the representation of sigma and pi bonding. While sigma bond is formed by head-to-head overlap, end-to-end or axial overlap, pi bond is formed when orbital overlap in parallel fashion or side-by-side overlap. In sigma bond formation, there are three possibilities. Here, S and S orbital overlap, S and P orbital overlap, and P and P orbital overlap. While in pi bond formation, P-P overlap occurs. First, we discuss sigma bond. Sigma bond is a covalent bond in which the electron cloud overlap is directly between the nuclei of atom involved in the bonding as we discussed earlier. A sigma bond will form using electron in s orbital, p orbital or hybrid orbital. A sigma bond will always be a single bond. Before going to discuss the example, first we have to take the electronic configuration of hydrogen atom as it has only one electron in its outermost shell. As we have two hydrogen molecules, each having one electron in s orbital. S orbital have a spherical shape. This is the example of a sigma bond as one electron from one hydrogen and one from other. When these two overlap, there will be a formation of sigma bond here. The overlap of two atom cloud is directly between the nuclei of two atoms. Before going to our second example, we first see the electronic configuration of chlorine atom as it has one electron in 3pz orbital. Chlorine atom has 7 electrons in its outermost shell, so the bond between the atom is formed by the overlap of 3pz from one chlorine atom and 3pz of other chlorine atom. When they get overlapped, they form a sigma bond. These black lines are showing the overlap, and the overlap is directly between the nuclei of two atoms. Third example is hydrochloric acid, as hydrogen has its one electron in s orbital and chlorine has its one unpaired electron in the p orbital. They get overlap. The overlap is directly between the two nuclei. The bond formation here occurs as a sigma bond. Our next example is CH4 methane, as here carbon has sp3 hybridization and it has tetrahedral geometry. Before going to discuss it, we have to look at its electronic configuration. In ground state, it has 2 unpaired electrons, while in excited state, it has 4 unpaired electrons which get involved in the bonding. Here, 4 sigma bonds are formed, 3 by S and P overlap and 1 by S and S overlap. Our next example is BCl3, as boron atom has sp2 hybridization. It has electronic configuration 1s2, 2s2, 2p1. In the excited state, it becomes 1s2, 2s1, 2p of x1, 2p of y1. It have 3 unpaired electrons. These 3 unpaired electrons combine with 3pz unpaired electron of chlorine and form 3 sigma bonds. Moving to our pi bond, the second and third bond that form in the double and triple bond are pi bonds. You cannot have a pi bond if there is no sigma bond earlier. A pi bond can only be formed by a p orbital that is not involved in hybridization. The overlap of orbital in a pi bond is not directly between the nuclei of atoms involved in bonding because p orbital has two lobes. So the pi bond actually has two half sections. We can take example of ethene where we see double bond. First bond is the sigma bond and the second bond is pi bond. Double bond is formed between two carbon atoms. Now it gets strange. The pi bond is the second bond in double bond while first bond is sigma bond. In this case, ethene has a planar geometry and carbon atom has sp2 hybridization. It involves 2s and 2p of x, 2p of y, while 2p of z remain unhybridized. Firstly, sigma bond is formed, then unhybridized 2py and 2py of second carbon form a pi bond. So here one sigma and one pi bond is formed. If we consider a bond between hydrogen atom and the p orbital of carbon atom, then it means there are total 5 sigma bonds pointed by hand. The red lobe shows the p orbital that were not involved in the hybridization. They extended above and below the area that directly joins the nuclei of carbon atom. Pi bond has two holes, one above the plane between the carbon nuclei and the other below the plane. A double bond starts with a sigma bond that usually involves hybrid orbital. Next example is acetylene or ethene. The triple bond between carbon atoms. There are 3 sigma bonds in the molecule, one connecting each of the hydrogen atom to the carbon atom and the other joining two carbon atoms. There are also 2 pi bonds between carbon atoms. Here you can see 3 sigma bonds. Carbon atom is using sp hybrid for a sigma bond, therefore the molecule is going to be linear in shape. To understand the pi bond formation, first is electronic configuration in the ground state. There 2p of x and 2p of y have an unpaired electron. In the excited state, you can see 2s, 2p of x, 2p of y and 2p of z has the unpaired electron. Now 2s orbital of one carbon atom can make sigma bond with 2s orbital of other carbon atom. 2p of x of the carbon atom can make bond with hydrogen atom and second carbon with other hydrogen atom. In this way, 2py of one carbon atom can make pi bond with 2py of other, and 2pz of one carbon atom can make pi bond with 2pz of as 2p of y and 2p of z are unhybridized, so they will form pi bonds. One of the pi bond involve the top and bottom overlapping, and the next pi bond involve front and back overlapping of blue color p orbital. So that's all about our today's video. Thanks for watching. See you in the next video. Allah Hafiz.